This question here, we're looking at triangles and working with them, and we're looking at calculating sides and angles associated with triangles. Now, one of the big rules that pops up in our head when we're thinking about triangles with sides and angles is either a SOHCAHTOA or Pythagoras theorem. Now, the issue with the pair of those is that they only work on right-angled triangles. But at this level, we've learned two other rules, the sine rule and the cosine rule, which can apply to any triangle out there, whether they're right-angled or not. Now, in this case, they're the rules that we're going to be working with here. We can look at this triangle. Your brain might say, well, it almost looks right-angled, but in maths, we can never assume things. We have to prove them. We can't assume this is right-angled, so we can't use sine, cos, tan, or we can't use Pythagoras. We have to use sine rule or cosine rule. Now, it wants me to calculate the length of a side AB. When you're working with something like this, and it's a generic triangle, and you're picking between the sine rule and the cosine rule, ask yourself the question, am I working with sides and angles opposite each other, or am I working with sides and angles where the angle is made by sides? So in this case, what I'm working with is I have the angle cos C, so this angle down here, and it is made by two known sides that I've got, and I'm calculating the side opposite the angle. What this means is this tells me that I'm going to use the cosine rule. If it was sides and angles opposite each other and I had another angle, let's say the angle at B, if I had that, then I could start to use the sine rule. However, I don't. So I have to use the cosine rule in this case. So what the cosine rule is it tells me a squared is equal to b squared plus c squared minus 2b c cos A. That's the cosine rule written out in generic form. Again, this appears in the formula sheet at the start of the exam, so if you have a brain fart and you forget, you can use it to help you and refresh your memory. Now in this, the B and the C are the sides that make the angle. The cos A is the side, that is the angle, that is made by those sides. So in this case, that's the equivalent of my cos A. Yes, it's labelled C in the diagram, but it corresponds to that part of my formula. Now in this, I can say that the A is equal to the side AB in this case. My B and my C, I can label them as the other two sides that I know. Now, it doesn't matter which way around you name them. So I can make B5 and C6, or I could have made it the other way, B5 and B6, and C5. Wouldn't matter with the way the operations work. I also then have to do whatever cos A is. Well, cos A is the equivalent of the cos C for this triangle. Now, I haven't told you, and you don't get given, the actual angle itself. That's frustrating because we can't calculate the value for it. However, if we go back and look at the information in the question, we are told that cos C is equal to a fifth. Now, if cos C is equal to a fifth, that means the cos A part of our formula is equal to a fifth. So that means that for the whole of this cos A here, we can use a fifth. Now, this causes a lot of errors sometimes because some people think that if cos C is equal to a fifth, what that means is it's cos of a fifth, and that's what they put in. No, that is wrong. You're substituting for the whole of the cos A part being equal to a fifth. So what that means is in this case, I'd have AB squared is equal to 5 squared plus 6 squared. Take away 2 times 5 times 6 times the cos A, which according to this part here we know is a fifth. So note, I've taken the entirety of the cos part out. What I can then do is start to simplify this and work it all. So I know AB squared is equal to 25 plus 36. So I'm going to be take away 2 times 5 times 6, then times a fifth, ends up giving me 12. So simplifying that even further, 25 plus 36 is 61, take away 12 is 49. So I know AB squared is equal to 49. So AB is equal to square root of 49. So we know then that AB is going to be 7 meters for this triangle here. So we've calculated it through and we've figured out the value for AB based on the information that's there. Now this question here is worth 3 marks. First mark is for getting to this stage, so interpreting that we have to use the cosine rule and the parts of it and writing it out. Second mark is for getting to the AB squared equals 49. And then the third part, remembering to take the square root and getting that AB is equal to 7 meters. Now being able to recognise which rule we use, so cosine rule or sine rule, and which variation of them we use, is a vital thing to be able to do. So have a look at that and make sure you can identify, am I using sides that make an angle? Am I using all 3 sides of a triangle with no angles in it? Or am I using pairs of angles and sides that are opposite each other? Whichever one of them you can say to yourself, yes, I'm doing that, or yes, that's the information I've got, that will help you get towards the rule. And if you can do that, the maths involved in it is relatively straightforward, particularly in calculator papers when you have the calculator to hand and you can have the extra confidence with it. And if you're able to do that and work it through, a question like this can become very straightforward and it can be easy peasy, lemon squeezy.